When I was little, my father was famous. He was the greatest samurai in the empire. He cut off the heads of 131 lords. He was the greatest samurai in the empire. And he took me with him.
Hey everybody, as you all know by now, last year I put out a video called 11 Questions Flat Earthers Are Afraid to Answer, and I got a whole lot of replies, but the vast majority of them were asking me questions instead of answering them. Now, since I started calling out flat earthers on this fact, they've actually started coming over and answering some of them, but that's just y'all trying to save face, and we all know it. Now, the answers flat earthers gave are all over the map, but the one question with the most consistent answers was my second question. Why do the sun and moon rise and set the way they do, disappearing bottom first and reappearing top first, and doing so at different times, and doing so according to the longitude on the Earth? Unlike my first question where I got 18 different answers from only 30 people, with this one I got 117 people who responded with one or more of the following concepts: perspective, vanishing point, limits on the human vision, and or lensing, magnification due to the atmosphere. Almost all said perspective. Some added in one or more of the other concepts, which is very consistent, so I have to commend you for that. That tells me that in this case, flat earthers really think they have an answer for this one. Too bad their answer is really, really wrong, because perspective does not like the flat earth setup. The basic rules of perspective are as follows. Objects that are near the viewer appear larger than the same objects farther away. And parallel lines, though in reality they do not converge, will appear to converge at a point on the horizon known as the vanishing point. That point is not a real point, it is an imaginary location infinitely far away. Now, from a globe model point of view, the observer's distance from the sun does not change much over the course of an afternoon. It's still some 93 million miles away. So there would be some reason for a change in apparent size of the sun, a very, very minor change in size. The flat Earth concept, however, has a nearby sun, and so any change in distance would be a significant change in distance, and so we should see a significant change in size, which we do not see. Now hold on, I know that flat earthers scour for footage wherever they can for a sun that is looking big high in the sky and then looking smaller toward the sunset, and those videos do exist. Now, I could argue that those videos show a sun with a tremendous amount of glare, looking big, high in the sky, and then as the sun sets and the light gets dimmer and thus less glare, we start to see the sun for the size that it is. But I won't go any further than that. I can talk about how some have put a solar filter on their camera to dim some but not all of the glare, and there's still a noticeable change in the size of the sun, though it's not very much. And I can talk about this footage that I took of the sun in the morning and in the afternoon with an eclipse filter eliminating nearly all of the glare, and how there is barely any change in size whatsoever. A pixel? 2 if I'm super generous? But I'd rather talk about how much size change should be seen if perspective were at work, because perspective has rules, and those rules are based in math, and so we can calculate what should be seen. You see, not only do objects look smaller when they are further away, they look smaller in proportion to how far away they are. If it is twice as far away, its width would be half the size. That's inverse proportion. 3 times as far, 1/3. 10 times as far, 1/10. Now, since flat earthers don't have a working model and get upset with me every time I claim to be using their model, I will just generalize what I've heard them say about the size and distance of the sun. For the sake of having nice round numbers, we will have the sun over a flat Earth be 50 kilometers wide and 5,000 kilometers above the surface. At high noon in Kenya, right on the equator, the sun is 5,000 kilometers from the observer, and it looks a certain size. 6 hours later, during the Kenyan sunset, it's high noon over central Brazil. That's the sun being 5,000 kilometers overhead in Brazil, and that's 10,000 kilometers away, which means the sun is now a squared plus b squared equals c squared, 11,180 kilometers away from the folks in Kenya. That's nearly 2.25 times as far away as it was at noon. So it should be about 45% the size it was at noon. Has anyone out there seen a solar filtered image of the sun at high noon and again at sunset with a size change of 55% in its diameter? No. Why? Because a nearby sun absolutely fails the perspective test. Yes, it does. And how do I have the nerve to make such a definitive statement? Because a lot of you flat earthers agree with me. Some time ago, influential flat earthers finally had to admit that perspective could not explain the appearance of the sun and moon, and so they made something up. Atmospheric lensing. That's right, flat earthers that have a nominal respect for science know that the sun and moon do not appear as perspective dictates they should.
How do the sunrise and sunset work on the flat earth model? And the flat earther will answer, perspective. Well, that is not enough. I mean, perspective is just a little part of the answer, but it's not enough.
But instead of accepting the model that already explains the appearance of the sun and moon perfectly, they decided to add another unknown to the equation, a kind of reverse Occam's razor. According to them, the water in the atmosphere acts as a lens and magnifies the sun and moon so they look big, even though they have actually gotten far away. And some of you are saying, yes, there are those videos where the sun appears relatively big and then disappears as a little dot. These flat earth scholars say that there are occasions when the atmosphere is dry enough that the lensing effect is gone or minimal, and we see the sun disappear as a point because it is so far away that our eyes don't see it anymore. It's the limit of human vision. They say that the sun is the same distance away here as it is here, but without the lensing effect to magnify it, we are seeing the sun's real size at that distance. And to them, I say, nope. Because once again, the rules of perspective slap flat earthers around. Let's go back to that sun that's 5,000 kilometers over our head. Now, at 50 kilometers wide, it takes up about 0.57 degrees in our vision. Now, the limit of human vision is about 1 arc minute, that's 1/60th of a degree, or 0.01667 degrees. So how far away from the observer would the sun have to be in order to disappear because we just can't see it anymore? Well, if it goes twice as far away to 10,000 kilometers, it will be 0.285 degrees, half the size. Let's go twice as far away again at 20,000 kilometers. That's 0.1425 degrees. Still nearly 10 times the limit of our eyesight, and it's already 20,000 kilometers away. It turns out to get far enough away to still be twice the limit of human vision, the sun would have to be 17 times as far away, or 85,500 kilometers away, and still somehow be overhead at some other location on Earth. Not only that, but the sun would have to have traveled that far in 6 hours. That's a whopping 14,000 kilometers an hour. Don't you think we would have noticed it hauling ass like that at some point? So why does the sun appear to shrink like this? I would say it's the glare of the bright sun and the level adjustments of the cameras. because the moon isn't nearly as bright as the sun, and thus doesn't have the same glare issues, and you never see footage of the moon shrinking away like this. It's just the sun. Why is that? Doesn't the lensing affect them both the same way? Is lensing magical? And yes, magical, because not only does it treat the moon differently than the sun, it treats the moon and the sun differently than it treats everything else. It really does. Even when lensing is not in effect and the sun is being seen at its true size, shrinking away, the stars stay the same size. The mountains in the distance, the planes flying in the distance, stay the same size, no matter what the moisture level in the air. Atmospheric lensing only affects the sun and the moon because they're special. So special that the sun and moon look the same size to a person on the ground as they do to a person 50,000 feet above them in a plane, even though the atmospheric conditions are completely different. So special that atmospheric lensing can take a light source that has gone so distant that the human eye can barely see it and make it big enough and bright enough to still read to. It's amazing. And not only that, lensing is so magical that it never affects when the sun and moon will rise or set. You would think that if the conditions were right for more lensing, that the day would get brighter sooner or stay bright longer. Ladies and gentlemen, sunset was supposed to be at 6:47 tonight, but due to the increased atmospheric lensing, we'll have another 30 minutes of sun this evening. Enjoy! Nope, never happens. The sun and moon rise predictably according to the observer's position on the Earth, no matter what the atmospheric lensing conditions are. And that's because atmospheric lensing, with the magnification properties that flat earthers have given it, doesn't exist. It's something that flat earthers made up in order to compensate for the fact that perspective cannot explain the appearance of the sun and moon in a flat earth system. It fails perspective so badly that I'm not even getting into how that's supposed to explain why the sun and moon set over the horizon. That's like asking it to run a 100-meter dash when it can't even crawl. I would tell flat earthers to do better, but I honestly think this was the best they could do. And that's just sad.
That's my job! That's what I do! I don't lose! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.